Hi guys, this is just a really quick video to run you through the use of the NSight IDE and the debugger on Bubaki when you're working with the Tesla card provided. So if you review lecture 20, you can walk through launching the NSight environment. I've already got it up here, and I've got my Conway's Game of Life example from last lecture up. I've made the code window, the font size nice and big so that you can see everything here. And we're going to start today by use this as a demo for using the debugger. Now, we've got our code all up, we've finished it, we're ready to debug. So to start the debugger, we can click on the little bug button up the top here on the menu bar. If you mouse over, it'll say debug whatever project you're working on, and when we go through that, it'll go through and do any of the building required, and then it'll pop up this nice little menu. Now this is the single GPU debugging beta feature warning menu. Essentially using the debugger on a single GPU that's shared amongst multiple users is only a beta feature, so it's a bit buggy and it's a bit clunky. And it's important that when you do this, the first time that you run this, you jump in, you go to the Open Preferences, and you have to enable the software preemption feature here. So you have to make sure that this software preemption checkbox is clicked. And you can also select which of the two Tesla devices that are made available to you you can use. If you select both of them, then it'll be randomly selected when you start. But it's important that you select this, and this will allow you to share the graphics card with other people, because if you go in and you don't click this, you'll lock other users out, and other users will lock you out. So you'll be able to lock the whole thing up. And myself and Norm will have to come in and kick you off the graphics card and kill all of your processors. So make sure that you have that software preemption checkbox enabled. And when you go in, it'll ask you if you want to change to the debug perspective, which you do. So if you jump in, it'll then bring up the debug window that you saw in lecture 20, and as you can see, we've got our line of code that we're currently working on highlighted, and we can step through. We can either step into that line or you can step over the line. Stepping over is only relevant when you've got a function call. So we don't want to step in to this malloc call, so we're not particularly interested in what's going on in the inner workings of malloc, so we can step over that one, and we can of course we can mouse over and see the results if we mouse over the elements array here. So if we go to the Conway grid structure, we can open that up, we can get onto the elements item here, and we can even view that. You can view that as an array. So if we view the first 10 elements of that, you can see that we've got nothing in there. It's all brand new memory. So eventually I'm going to go down and drop a breakpoint down just before, so I'm going to right click and toggle a breakpoint down just before my kernel launch, and I'll continue down until that point. We already had another breakpoint in there, sorry. Now we're ready to go down. We're now ready to launch our CUDA kernel. So if we jump to the next instruction and then we step in to this instruction, there can be a little bit of tricky stuff here that you've got to jump through. You can just jump through all of those bits and pieces. We're now stepping in. Oops, if we just hit over a couple of times, might have to do some tricky bits and pieces, and eventually you'll end up, if you step through enough of the little bits of code that connect your main program to your kernel, you'll eventually be taken in to your CUDA kernel. Now you can see that it's that I've skipped to this line here. We're now inside the GPU. If we look up here on the debug pane in the top left, there's some additional bits and pieces, and this all kernel threads. It's really interesting because we can open this up and we can open up every single block, and we can see each individual thread, and if there's multiple warps, we can even see multiple warps. In this situation, there's only one warp. So you can go into those individual threads and actually display the items in there. So if we open up the TID, for example, that's the only calculation that will be different in each of those threads. You can see that in thread number 15 from block 0, we've got a value of 15. So that allows us to then step through the lines of code on our kernel and see what's going on. So it's quite nifty stuff. Now it is a little bit clunky and buggy. So you saw there that I actually lost control of that one. I had to go and reselect some bits and pieces, but it allows you to debug and see exactly what's going on in your kernel. Makes it much more easy to develop your code as you move through. So I'm stepping through, I can see the values, and you can inspect each of these items. You can either mouse over them, or you can watch them up here in the pane up on the top right hand side. So once you've finished up your debugging, you can either continue on, or you can, and it'll terminate for you, or you can hit the stop button. You can see that it's printed out bits and pieces down on the command line here. These are just from other projects that I've got open, and essentially you can then switch back to your main perspective and you're good to go then. So that's all I've got. So that's just a nice little demo of using the NVIDIA NSight debugger to debug an actual CUDA kernel. Again, I reiterate, when you launch the debugger, make sure that every time you launch it with the software preemption available. So that allows other users and other processors to access the graphics card during your debug session. It won't affect you in any way. You'll still be able to debug as normal. It just makes sure that you don't hog the graphics card, and we don't have to come in and kill your processors so that other students can use it. So jump into that one and have a play around with that NSight debugger. And thanks for listening, guys.